Hi, this is Purnima Mahalingam, and you're watching video lecture series on solar and wind energy systems. This is a new video lecture, and welcome back to this channel. Let's go and see the video. Okay. Today, we are going to discuss about modern wind turbine technologies, which is powering the futures. In this slides, we are going to discuss about the wind energy is a critical component of the global energy transistor. So by 2023, the world has installed 1,047 gigawatts of volts capacity. This accounts of 88% of global electricity generations. So this is what a small introduction about this topic. Come, let's go into the topic. So next, here we can see the evolutionary of wind turbine. Here, first evolutionary. So early windmills. What about the early windmills? Here we can see the pictures. So early windmills, how it was. So in early windmills is the usage of milling grains and pumping waters. This is what early windmills are used for. Applications were for pumping of waters and milling grains. So for that purpose, the windmills are used. So later in 20th centuries, there comes the introductions of modern designs. Here we can see that after 20th century, here comes to the some modern designs. Since in 2000s, the average turbine capacity increases fivefold. So in 2000, really since 2000, here we can see the modern turbine, modern technologies. Here it is increase of fivefold. So greater than the fivefold. And today, the rotor diameters now exceeds to 250 meters. You can see that in pictures. Now it is exists about 250 meters. So this wind power has evolved from simple windmill to mega giant. And this technology progressive drives the efficiency, all about the efficiency. Okay, now coming to the onshore wind turbine and ground break efficiency. Here, what about the onshore wind turbines? Here comes about the specification. Here are the specification. What specifications we are going to use? So typical capacity is about 2 to 7 megawatts per turbine. So per turbines, what about generates 2 to 7 megawatts, and hub height. So hub height is normally 80 to 120 meters for optimal wind captures. For optimal wind captures, so minimum of 80 to 120 meters is needed. So what is the advantages of this is that is cost effective due to the mature supply chains, and it is in a cost effective and easier access for installations and maintenance. This is what an main advantages of this offshore wind turbines. And what an example is Versata, that is V162 -6. This Versata produce 6.2 megawatts, the popular onshore model. This is what an popular onshore model. So the onshore wind turbines offer efficient, which is cost effective, and power generations. They leverage infrastructures for renewables. This leverage is an establishment infrastructures for renewable. So next, coming to the offshore wind turbine. Here comes to the offshore wind turbine. What happens here it is, what is comes up first time comes up to capacity. So the giant of sea, the offshore wind turbine is a giant of the sea, is capacity that is 8. So 18 plus megawatts is a per turbine, and wind turbine wind speed is high, most constrained wind yield, that is 40 to 60 percentage of capacity factors. And what is the foundation? It is specific monopile jackies, gravity based needles. And the example for this is GE Hales. GE Hales that is 14 to 15 megawatts. The Siemens gains at SG, that is 14 to 236 TD, and that is 14 to 15 megawatts. There are offshore wind turbine, there is harness, power marine winds, and they requires robust engineering solutions. This is what an offshore wind turbine. Now coming to cutting edge involved. What are the cutting edge involved in this wind turbine? It is What is the cutting edge involved in this wind turbine? It is advanced blade design. This is, yeah, here we need is advanced blade designs. Here we can see, and the carbon fiber components offer strength and lightness. This is the carbon fiber. It is made up of carbon fiber. Mainly, it is useful for the strength and lightness. So our next one is the smart control, that is pitch, yaw, and light optimized power outages. So we need a smart control, pitch control, yaw control, etc. And digitalization, that is SCADA systems, which is enabled remote monitoring and predictive maintenance. So the remote monitoring and predictive maintenance is the main process, the main process we have to take up. And next one is improved drive time. Improved drive train. What in direct drive generator reduce moving part, enhancing reliability. So innovations are transforming wind turbine capacities. They enhance the efficiency and reduce maintenance needed. This is what an important innovations are transferring wind turbine capacities, which enhance the efficiency and reduces the maintenance needed. This is what an cutting edge in innovations. Now coming to the um, performance and economic importance. We have noticed, so it is a 59% in onshores and 73% in offshore loops and 1.2 megawatts global created by the wind sectors. So wind energy become one of the cheapest form of the new generation electric generation. So the economic efficiency also fuels significant job creations, etc. So these are about the performance and economic impacts of wind energy. Okay. Finally, this is an environmental contributions and grid integrated. What is environmental contribution? Is CO2 avoidance, carbon dioxide, and energy security and digital, grid solutions. So environmental and it is in security and grid solutions. This is what an environmental contributions and grid integrations. Okay. With this, today we are going to end up this video and we'll meet in another video. Thank you so much for watching. Thank you so much.